Okay, let's take a look at Chapter 10, Test Review. And there we go. Test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. We got H naught is equal to this. Okay, looks like a population proportion. And I believe that's 10.2. So let's bring that up. And okay. So okay, p-value approach using the TI3, TI4. Now some of the information they give it to us direct, so let's go ahead and write that down. Got H naught is P is equal to 0.6 versus H1. P is greater than 0.6. N is 100. X is 75. And alpha is 0.1. First off is N times P naught times 1 minus P naught greater than or equal to 10. N is 100 times P naught. 100 times 0.6, 60. Yeah, it is greater than or equal to 10. The reason why is 0.6 times 1 minus 0.6, that's 0.6 times 0.4, which is 0.24, which times 100 is 24. Okay, use technology to find the p-value. And they tell us here, we're going to be using one prop z test. They don't really give this claim. They dive right in with H naught and H1, so we can't really do step 1, can't really do step 3. So let's go to one prop z test. Okay, so I go to stat, and go to tests, and one prop z test, number 5. It's asking us for P naught, that's a number off of our claim, which is 0.6. It's asking us for X, which we said was 75. It's asking us for N, which is 100. The symbol on H1, which is a greater than. So I'm going to write her over to the greater than, and I'll press enter on it. Mine's already selected, but in case yours wasn't, that's what you'd do. Down arrow to calculate, and press enter. And this is our p-value. And they want it rounded to 3 decimal places. So it'll be 0.001. Okay. Now, for our conclusion. It says that p-value is less than alpha. Alpha is 10%. And this is 0.001. So it is less than. So that says reject H naught. So we're going to reject the null hypothesis because p-value is less than alpha. And next question. Okay, previous poll. Let me get back over here. Back to my tablet. There we go. The previous poll, 45% of adults with children under the age of 18 reported they ate dinner. Okay, suppose in a more recent poll, 553 of 1,200, so N is 1,200. It's always your larger number. And 535 report that they ate dinner together. Okay, is there sufficient evidence that the proportion of families with children under the age who ate dinner has decreased? That sounds like our claim. So decreased is less than. And up here they're referring to 45%. So if they don't give you a value direct, you look up to like first sentence or something to see if they refer to what the old percentage was. Okay, and we're talking about P. Less than goes on H1, and this would be greater than or equal to, following the Book's convention. Okay, what are the null and alternate hypotheses? Well, H naught we said is P is equal to 0.45, and H1 is less than 0.45. Now we need to use technology again. Well, that's one prop z-test. So do stat, go to tests, one prop z-test. P naught is a number off of our claim, which was 0.45. X, what was X? X is 535. N is 1200. The symbol on H1, which is a less than, so I'm going to right arrow over the less than and press enter on it. Down arrow to calculate, and press enter. And p-value, do they want a p-value? Yeah, they do. 3 decimal places. 0.386. 386. Okay. Now they're specifically asking about the claim. So let's finish our process here. We said p-value is equal to 0.386. It says down here, if p-value is greater than alpha, pretty sure it's greater than alpha, but let's see what alpha was. Alpha was 5%. So if p-value is greater than alpha, it says we accept H naught. We're going to accept H naught, which means we'll reject H1. Now notice the symbol on our claim is a less than, and the symbol on H1 is a less than. So our claim, not clam, our claim matches H1, so whatever we say about H1 is what we say about our claim. We just rejected H1, so we're going to reject our claim. Okay. Oh, they're asking about the null hypothesis. What did we say about the null hypothesis? We accept H1, which means we do not reject it. Okay, here's a do not reject null hypothesis. P-value is greater than the level of significance. That's sometimes wording on these, you really have to read them carefully. Here's another do not reject the null hypothesis. P-value is greater than, yes, there's sufficient evidence. What in the world are they asking? Okay. Is there sufficient evidence that the proportion has decreased? Okay. Decrease is the claim, which matches H1, and we said we're going to reject H1. Is there sufficient evidence that it has decreased? We said we reject that, so that's no. Okay. Therefore, do not reject null hypothesis. So that's one word. Well, wording is kind of tricky there. Let's take a look at this one. Okay, previously 28% of parents of children in high school felt it was a serious problem and they were not being taught. Okay, a recent survey found that 99 of 300, so N is 300, and X is 99, felt it was a serious problem. Okay, do parents feel differently today? Different then. That means not equal to what it was before, so not equal to 0.28. Different than 0.28. And alpha is 10%. Okay, so our H1, or H naught and H1, this is P, and not equal to goes here, and equal to would go right there. Okay, so H naught is an equal to, 0.28. And this is a not equal to 0.28. Use technology to find the p-value. So go to stat, tests, 1 prop z-test, 5. Number off of our claim, which is 0.28. X, which was 99. N, which is 300. The symbol on H1, which is a not equal to, so press enter on not equal to. Down there to calculate and press enter. And 3 decimal places, we get 0.054. 0.054. Okay. If p-value is less than alpha, alpha is 10%, this is 0.054, so it is less than. It says we reject H0. So we reject H0, which means we accept or we fail to reject H1. And our claim matches H1, so whatever we say about H1 is what we say about our claim. So we'll fail to reject or we'll accept our claim. Okay. Do parents feel differently today? And we said we accept that they do feel differently. So the answer is yes, one of these two. There's mean that we do not reject the null hypothesis. What did we say about the null hypothesis? We said we rejected it. Okay. So next question. Okay, critical values. So determine the critical value for right-tailed test of population at mean is equal to 10%, level significance. Oh. This table right there. Okay, I was wondering how I was going to find it. Okay, so for our first one here, with 10 degrees of freedom. So we're going to look up 10, and it says for a right-tailed test. Well, let's draw a picture so we can understand what's going on with that. Okay. So it says for a right-tailed test, we got a right tail, and alpha is 10%, so I'll put 10% there. If that's 10%, then this will be 0.90. And this is the value we're trying to find. Okay, so we got that 10 degrees of freedom. Let me click this. We're going to look for the 10 degrees of freedom row. And this is area in right tail. It should actually say area in one tail, not area in the right tail. But in this case, it is a right tail. It's 10%. So we're looking at 10%. Come down here. And it says 1.372. So 1.372. For our next one, it's left-tailed. So let's draw a picture. So left tail, alpha is still 10%, which means I'm putting the 0.10 there, and this would be 0.90, and this is what we're trying to find. Well, we look it up in our table. We're still doing degrees of freedom of 10, I think is what it was. But we're looking at 0.10, and this again should say area in one tail. So look up 0.10, and that's 1.372. And it helps to actually read. Based on a sample size of n is equal to 15. So our degree of freedom would be 14, because there's always one less than n. Okay, I'm going to look that up again. So 14, then come here, and that tells us 1.345. 1.345. And since it's on the left side, then we make it negative. So negative 1.345. And then the other one is two tails. And how much is alpha? Alpha is 1%, which means we split the 1% in our tails, so that'd be 0.005, and this will be 0.005. And we're trying to find two values here. This will be a minus version of it, and this will be a plus version of it. It says that our sample size is 12, so degree of freedom is 11. So let's go look up 11 and 0.005 and see what we get. So area in one tail is 0.005, and 11 would be 3.106. 3.106. So this is a negative 3.106, and this is a positive 3.106. So we're going to have a plus or minus 3.106. Next question. Let's see, mean is here. Okay, compute the test statistic. (10.2), that would be 10.3, I guess. Get that to come up here. A little slow. There it is. Here's our classical approach, which involves a test statistic. And so let's go through the claims, see what we got. Okay, to test H naught, I guess they're giving that to us direct, so not giving us a claim. Mu is equal to 50. And H1 mu is less than 50. Random sample size n is 23, so n is 23. Obtained from population normally disputed. Okay, X bar is 47.1. S is 11.7. Since it's a small sample, it's required to be normally disputed, but that isn't really pertinent to actually find a test statistic. Except for that, we can't do it without doing that. Okay. So to find our test statistic, we got this. Okay, see if your claim matches H naught. We don't got a claim. Draw the picture. Less than, it would be over here. And then we want to split our alpha into the tails. Alpha. What is alpha? There it is. Alpha is 5%. So I'll put 5% here. I like following my steps for this. Then 95% is here. And this is going to be our test statistic, critical value down here. We'll come back to that. But what they're asking for specifically at this point is a test statistic. So we're skipping step 5, the critical value. Test statistic, t-test. So let's go do the t-test. So we go stat, go to tests, t-test. Data is when you're given raw data. Stats is when giving you summary statistics. We want summary statistics. Mu naught will be the number off of your claim, which was 50. X bar we said was 47.1. S is 11.7. N is 23. The symbol on H1 is a less than, so I want to write her over and press enter on less than. Down arrow to calculate and press enter. And our test statistic, rounded to something, 3 decimal places, will be negative 1.189. So test statistic, negative 1.189. Okay. And okay, we use find the critical value. And we do this with the t-distribution table again. Now our area in one tail is 0.05, and our degree of freedom, since n is 23, our degree of freedom is going to be 1 less, which is 22. So I'm looking up 22 for degree of freedom and 0.05 for area in one tail. here's 22, and degree of freedom, okay, 0.05, there it is, 22, oh, my eyes are bad, 1.717, 1.717, and since it's on the left side, it'll be negative. If it's on the right side, it's positive. So negative 1.1.1717. There we go. Draw a t-distribution that depicts the critical region. What do we have? It was a left tail. Okay, null hypothesis. Well, this is the number line. Negative 1.189 would actually fall over here if we think of that as a number line. And it says if your test statistic falls in the main body, you accept H naught or you fail to reject. So we're going to accept H naught. What did I say? Accept H naught. The test statistic falls in, accept H naught. Will they reject it? No, they will not reject it. Because the test statistic does not fall in a critical reason. Okay. Number 6. Let's see what it says. To test H naught, mu is equal to 100. Against H1, mu is not equal to 100. Simple random sample size 24, so n is 24. X bar is 104. S is 8.7. And it wants us to compute the test statistic. Well, if we go through our steps here, we don't have a claim, so don't do step 1 and step 3. We draw our picture. Not equal to says we've got two tails. And we're going to split our alpha into our tails. Alpha, I don't know what it is. Alpha is 0.01. Which means this will be 0.005 and this will be 0.005. We're going to have two critical values. We're going to need to look this up in a degree, using our degree of freedom, which will be 1 less than n, which is 23. And if 1% is in the tail, then this will be 99%. Not that we don't need that, but okay. Now step 5, find the critical values. Let's go ahead and just follow my steps here for t-distribution table. So we're looking up the area in one tail, which is 0.005, and degree of freedom of 23. 0.005, where is that at? There it is. And 23, which would give us 2.807. 2.807. 2.807. 2.807. Since this one's on the left side, that'll be a negative. Now it says the critical values are, then use a comma to separate the answers. So I'm going to have negative 2.807 comma 2.807. Then it says find the test statistic. We're going to use t-test. So let's go over to our calculator. We'll go to stat, go to tests, go to t-test. And we've got summary statistics again. So go down to mu naught, which is the number of our claim, which is 100. X bar, which is 104. S, which is 8.7. N, which is 24. and symbol off of H1, which is a not equal to. So I want to choose that one. And then I'll choose calculate. And the test statistic is right here, and I think they're wanting it 3 decimal places before, so I'm assuming it's staying. T is equal to 2.252. 2.252. 2.252. Okay, we got 2 tails right there. Now to the tricky part, the wording. My test statistic would fall in the middle here, in the main body. Falls in the main body, that's our accept region for H naught, or do not reject, which means we'll reject H1. Okay, what's it saying? Will researcher reject the null hypothesis? No, we're accepting it. So the answer is no. So it'll either be C or D, it looks like. And let's see, the test statistic is not between the critical values. Since the test statistic is between the critical values. It's kind of a weird way of putting it. It actually falls in the main body. But I guess technically that would be between the critical values. Okay, I'll go with that one. Wording on these is interesting. Let's see what this next one says. Okay, we're done with mean again. Okay. Several years ago, the mean height of women 20 years of age or older was 63.7. Well, that's kind of worded a little bit differently, but they're basically telling us that the old moo is 63.7. Probably's changed. That's what the claim is probably about. Suppose that a random sample of 45, so n is 45, who are 20 years or older, results in a mean height of 64.9. Now that's referring to the sample, so x bar is 64.9. Okay. Say it's appropriate to assess whether women are taller today. Taller. That's greater than. So they're saying they're greater than the old value, which is 63.7. So that's our claim. These are moos. Greater than goes on H1, so that'll be greater than 63.7. And this will be a less than or equal to 63.7. Since it's a greater than, it means it's a right tail. We have one critical value. Maybe they're not even going to give... Oh, there it is. 0.05. Alpha is 0.05. So 5% goes in the tail and 95% goes in the main body. And I don't see a little button for the test statistics. They're not going to, or the critical values. I guess they're not going to ask us for that. Okay, state the appropriate null and alternate hypothesis. H naught is equal to 63.7. So it's this one. Wouldn't be these last three here, so it's going to be one of these first ones. Equal, and this is a greater than. Okay, equal to, greater than. Equal to, greater than. Guys, I guess it'd be A. Suppose the p-value for this test is 0.07. Explain what this value represents. More wording. Let's see. Okay, so we're dealing with 63.7. Whose mean height is 60. Taller or shorter. So we don't want shorter. C's out. The exactly. So this is equal to, so that's out. So it's either going to be A or B. Let's read a little closer now. From population whose mean height is 63.7. So we're saying the population is 63.7, so it'd be that one. Okay, write a conclusion. Alpha is 5%. So p-value is 0.07, so it's greater than. So it'd fall in the main body. I could also look here. Maybe. Where's it at? P-value is greater than alpha. It says you accept H naught. So do not reject H naught. Do not reject null hypothesis. That's a possibility, and this one is. Okay. There is not sufficient evidence. There is sufficient evidence. Okay, so they're asking us about it's greater today. So asking us about H1. If we do not reject null hypothesis, or we accept it, that means we're rejecting this claim. Okay, so that'd be A. Boy, the wording on this is very interesting. Got a drink. I'd be shocked if I don't miss one or two just from the wording. Let's see. Okay, we're talking about this one. And so right-tailed test with 16 degrees of freedom. Let's draw that picture. Got a right-tailed test. 0.01. So alpha goes in the tail. And then this would be 0.9. And this is what we're trying to find. And when you're using the chi-square table, it's always based upon the area to the right. So the area to the right of this value is 0.1. So we're looking up. Area to the right is 0.1. And the degree of freedom will be 16. They're telling us directly. Okay. So 0.1 right here. 16 is 23.542. 23.542. Okay, left tail, part B, left tail test. Alpha is 0.01. If that's 1%, this has to be 99% here. We're trying to find this value, so the area to the right is going to be 0.99. And our degree of freedom, N is 25, so degree of freedom is 24. So let's go look up 0.99 and 24. 0.99, second column, and 24 would be 10.856. 10.856. 856. Okay, two-tailed test. And alpha is 1%, so I'll split that up. I'll put half of it here and half of it here. And if 1%'s in there, then 99%'s here. Now we got two values we're looking up. This first one, the area to the right is going to be 0.005. On this one, the area to the right will be, you have to add up all the area to the right. 0.99 plus the 0.005, so that'd be 0.995. My degree of freedom on both of those would be N is 31, so degree of freedom is 30. Okay, so let's go look those up. 0.995, 30. 13.787. So 13.787. And for this one, the area to the right is 0.005, which probably is our far right column, which it is. Come down to 30, and we get 53.672. So 53.672. Let's go round to 3 decimal places. 13.787, comma 53.672. 672. Next question. Okay, giving us another claim. Moment of truth's coming up here pretty fast. Whether I can actually read what the problem's saying. 2.8. Blaming a lack of sleep. And sigma is less than 2.8. Random sample of size n is equal to 17. And then be this. Okay, and S is 1.4. Our picture, though it's supposed to be a chi-square, but it's not bell-shaped. But our picture is a left tail. Doesn't really matter if it's chi-square or bell-shaped. Same idea either way. And alpha is 0.05. So put 0.05 in the tail and 95% goes here. We got one critical value. We'll need a degree of freedom, which will be 16. And the area to the right is 0.95. So let's go look that up. So go over here and use this table. Okay, degree of freedom of 16 and area to the right 0.95. 0.95, 16 would be 7.962. 7.962. Let's hope the numbers didn't change as I went over there. Okay, what's this one say? That's a test statistic. So the critical value is 7.962. Okay, our test statistic. I'm going to go look this up just to verify it, but I think our test statistic is n minus 1 times s squared over sigma naught squared. And let's see what we get. Okay, there it is. Okay, so we got n minus 1. N was 17, so I got 17 minus 1 times s squared, 1.4 squared, divided by sigma naught. That's a number off of your claim here. So we'll have 2.8 squared. Boy, that seems a big difference. 1.4 and 2.8. Did I write that down correct? Yeah, 1.4. Pretty good bet that that is true, but you never know some of the numbers you're given here. 17 minus 1 is 16. So I'm going to use that when I'm plugging in the calculator. So I got 16 times 1.4 squared divided by 2.8 squared. 4. Guess it is 4. Sometimes you have to make sure they don't actually give you a variance here. Let's see what they gave us. Oh, that was standard deviation. Okay, that's right. 4. Hardly ever does that come out perfect like that. Okay, what kind of picture do we got here? Left tail. The left tail is D. Okay, so our test statistic is going to fall over here. And our tail is always our reject region for H naught. So we're going to reject H naught. Will the researcher reject the null hypothesis? The answer is yes. It's going to be one of these two. This is our critical value, kind of weird notation. This is our test statistic. Test statistic is less than our critical value, so that is the correct one there. Last problem, then we'll see how close I read everything. Okay, H naught is sigma is equal to 2.5, and H1 sigma is not equal to 2.5. And it's going to be a two-tail, of course, because it's not equal to. Alpha is 10%. So we'll split 10% in our tail. There's 5% there, 5% here. 10%'s in the tail, then 90%'s in the main body. And we're going to have two critical values. We need our N, our degree of freedom, of course. N is 21, so degree of freedom will be 20. S is 2.2. Now let's look these up. First thing I'll do is look up this first critical value. And we look up the area to the right, which is 0.05, and degree of freedom of 20. We'll go back to here to use this table. So 0.05, degree of freedom of 20. 0.05, this column here, degree of freedom of 20 is 31.41. Okay, now I'm going to look up this second critical value, this one right here. The area to the right is 0.90 plus 0.05, which is 0.95 in degree of freedom of 20. So 0.95, degree of freedom of 20, I get 10.851. Okay, 10.851. So 10.851 and 31.41. Now our test statistic. Test statistic is from our formula is n minus 1 times s squared divided by sigma naught squared. So we're going to have n, which is 21. So we got 21 minus 1 times s squared. So put 2.2 squared over sigma naught, which is a number off of our claim. 2.5 squared. So we're going to have 20 times 2.2 squared divided by 2.5 squared. 15.488. 15.488. Picture-wise, is I need to read these closer. Depict the critical region. Critical region is always your tails, so that'd be this one. Wouldn't be this one. Hopefully, I haven't overlooked that in previous problems. Okay. Now our test statistic. Let's see where that falls. Falls actually in the main body. Now for our main body, that's always our accept region for H naught. Our tails are our reject region. So we're going to accept H naught, or we're going to reject H1. Okay. Let's see. Will the researcher reject it? No, we accepted it. So the answer is no. So it's either this one or this one. Test statistic is not in the critical region. Okay, so that'd be B. Okay, let's see how close I read. Last one. So close. Let's see. Oh, that's just great. I flipped those around. I'm shocked I read all the rest of those correct. But I guess why did I put the... Oh, it just seemed logical. The smaller ones should be here and larger ones here. Oh, well. But anyway, that's Chapter 10, Test Review.